Hi folks, as promised, I wanted to give a little bit of a refresher on how to do some of the exercises that have been assigned in lecture D2, and sort of as a side feature, this kind of will be sort of a crash course in Microsoft's equation editor, so that some of you can have an alternative to presenting your work other than sort of just scribbling on a piece of paper and trying to scan it in or something along those lines. And so there are ways to show your work in kind of a professional way, and the equation editor is not the best thing in the world to use, but it's not so bad in a pinch. So in this video, I'm just going to cover the derivation of a CDF from a PDF, and then in another video, I can actually handle the inverting a CDF in order to generate that random variate generator. So, so we're going to split these things up. So let's just start with a CDF, just because we kind of know what we're getting out. If I wanted to, I could say insert equation. Now I'm using a Mac, it shows here that if I do Control Enter, I can jump directly into this equation editor. So I could hit that there, or just right at my keyboard. You can probably hear me type it. I can hit Control Enter, and it says Type Equation here. And there's all these things you can select from up here. But if you use this a lot, you'll learn that there are all sorts of shortcut keys in order to simplify these expressions. But so as an example, I could type F. If I go into this equation here, I can type f of x is equal to, and then here I can actually say put a little curly brace and then type matrix and then an open parentheses, and you see that matrix turns into this funny little square, and then I can say x ampersand, well, let's say I'll do 0 ampersand x less than 0, at sign, x squared, ampersand x, I'll do 0 less than equal to x less than equal to 1, at sign, 1 ampersand x greater than 1, just as an example. And then I can do a close parentheses and a close curly brace. And the instant I type a close curly brace, then suddenly all that stuff that I typed in here turns into this thing, which looks like this funny little matrix. And so what you may have figured out is that backslash matrix that I was typing actually is a shortcut for typing in a kind of table format of an equation where all of the ampersands represent the column separators and the at signs represent the row separators. So if I click outside of here, you see that I found these funny little curly braces here. Now, if you go back into this equation editor and I right-click on here, and I say that I want, you may not have seen that, when I right-clicked on it, I clicked Professional. And what that Professional does is it makes sure it takes all those codes and it tries to clean it up to sort of figure out what you might have wanted. And since I put curly braces around this thing, it figured out that I wanted this curly brace to be big and this curly brace to be big. But when you write an equation like this, you never have that closed curly brace. And so I can now right-click on that and I can say Remove Closing Bracket. And then in a second, the computer's running a little slow because of the screen capture, it will remove that closing bracket. You see that? And now I have something that looks like a pretty decent little piecewise expression here. And you might add a little style, like maybe I'll put some commas here so that there's a nice kind of separation between those, something like that. But I kind of get the point. All right, so this here that I've written out, that you can verify, is a cumulative distribution function. So I know that because it starts at 0, and then from 0 to 1, I'm going to get rid of that extra slash here that I've managed to put in here somehow. Oh, it looks like it's just an italic cursor. So this x squared right here from 0, if I plug in 0 into x squared, it comes to 0. If I plug in 1 into x squared, it goes all the way to 1. So this x squared, I end up getting a nice curve that goes from 0 up to 1. And then once it hits 1, it stays at 1. So this meets everything we need to happen for a CDF. So then the question is, and then if I was on like a homework assignment, I probably would give you the PDF. And so I just copied and pasted that, and the PDF is pretty easy. I can actually just do piecewise derivatives, and so the derivative of a constant with respect to x is still 0. The derivative of x squared with respect to x is just 2x, and the derivative of another constant with respect to x is 0. And so now I've got the PDF here, and this was my original CDF. So you could imagine on a homework assignment, I might say, well, here is the PDF. Give me the CDF. So we want to, again, get this back out. So how do we do that? So there's a number of different ways you can work on this, but probably the easiest way is just to break this up into 3 cases. And you can say, okay, what if I'm in case 1 when so x is less than 0. So for case 1, and by the way, if you wanted to stylize this, I can highlight that, and then I can do that control equals, or go to insert equation, and it'll turn that x less than 0 into this nice inline equation there. All right, so for this case, I want to derive f of x, I'm looking for this sort of top row, but pretending that I don't know what that top row is. So I'm just going to do control enter, and then type f of x is equal to, and now I'm going to do \int, and so this is going to turn into a little integral sign. So I then do an underscore, and that allows me to set the lower limit. So in parentheses, I do minus infty, and that little code, and all of these codes you can actually find up in that ribbon, which you can see up top there under equation. But I just happen to know, these codes to make it easier so that I don't have to go up and try to find them in the ribbon. So that gives me that little negative infinity, and then if I do a little caret sign like that to x, then that will end up generating the subscript. And then you could say, well, that doesn't look very good. So, but if I then go to this equation and I do that professional trick like before, then bam, I end up getting something, a nice looking integral. So, and then you can go back into this thing and then go into this little box and then type f of x, or in this case I'll say f of u du. And you can even, if you look underneath, I think this integral here, I think they even have cleaner looking differentials. Actually, so like if I was doing this, I would have made these upright d's rather than tilted d's, but this is fine. For a Microsoft program, this is fine. So, it's readable. So that's kind of all that we care about. All right, so that doesn't look so bad, and that's just the definition of a CDF. For us, because we're in the case of x less than 0, we don't have to break this up anymore. We know that x is less than 0, so we know f of u is going to be 0 through this. It's going to be 0 through this entire period. So anything x less than 0, f of u is going to be equal to 0. So I could then write, if I wanted to, I could copy and paste. So I could take this thing, I could paste it here, put a little equal sign, and then I could say, well, that's just equal to 0 du, and then I could take this thing, again, a little equal sign, and I'd say, well, the integral of 0 is just 0, and I know that 0 goes from, so I'm going to do something crazy here. I'm going to do like this absolute value thing. I'm not actually sure if this is going to work, but I'm just trying it just for kicks here. So if I were to do that and then try that professional trick again, I'm going to see if it will, well, that doesn't look too terrible, right? This little absolute value thing. I mean, you know what I mean by that. And so, So basically then what that notation means is I'm going to plug x into 0, and that gives me 0, and then I'm going to plug negative infinity into 0, and that gives me 0, and that gives me 0 out here. So, all of these steps you could probably leave out. I'm just doing them all in here so you know they're in there, because again, these limits of integration are something that people forget about on this homework assignment. So it's just reminding you that these limits of integration are really important, and they become even more important for these or sort of second columns here. So now we know that that big F of x for this region, for x less than 0, is just equal to 0, which that matches what we knew that was going to happen. So, so that's good. So I'm just going to go down here and I'll say, all right, what about case 2? So case 2 is 0 is less than or equal to x is less than or equal to 1. You see I wrote it kind of in this programmatic language, but again, if I then go up to insert and then say equation, you'd say, but it still doesn't look that good. But if I go and I then go and I do that professional trick, then it turns those into these nicer looking ones. So you might even say that it might even be a little, you can maybe get rid of some of the space there. All right. So case 2. So in this case, now just because I've already done some of this work for me, I am going to copy some of this down here so that I can just start with this equation here. So I know, again, this is the definition of a CDF, but I know in this case I have to break it up into 2, because when I'm in this 0 is less than or equal to x less than or equal to 1 case, because the CDF goes from minus infinity all the way up to x, that means it's going to cross through this case that I've already done. So I actually need 2 of these integrals, and so I'm going to copy and paste and then play with the limits of integration. And this one is going to go from negative infinity to 0. And this one is going to go from 0 to x, because x is between 0 and 1. So this takes care of everything before 0, and this case takes care of everything from 0 to x, where x is less than 1. So, so this part here, I know I could just copy these here if I wanted to. And this guy here, I can say, well, you know what, I'm not even going to bother with worrying about this integral. I'm just going to backspace through this entire interval here. So this is where it gets a little tricky sometimes working inside a word processor, because if you backspace a little too aggressively, you end up getting rid of your whole equation. So, just kind of with some finesse here, coupled with the fact that my computer's running a little slow due to the screen recorder, I will just put a 0 here and see if it looks like it's not going to let me just delete that little bit of integral there. So again, the equation editor is not the most elegant thing, so I'm just going to end up copying just the little portion that I want over. Okay, look at that. So I just basically said this portion I know is going to integrate out into 0, so I'm not going to worry about it. And this portion is all the new part that I have to get, which is just going to be the integral of this thing from 0 to x. So I can take this and paste it in there. I'm going to get rid of the 0 because it's just a 0. And this f of u, I'm going to replace with a 2u, because that's just what's in the PDF there. And then I know that, okay, well, 2u, if I take the integral of that, then the antiderivative of u is u squared divided by 2, but then I multiply that by the 2, and I just get u squared out. So I know that I'm going to do this funny little absolute value sign here, which in this case doesn't mean absolute value. And I'll say my limits of integration are from 0 to x, just like that. And then, again, I can click away, and I can say, that looks ugly. But if I go and I either right-click or I look for that little pull-down and say professional, then it should, after some time, turn that into the subscript and superscript notation And I say, good. And then I can then say, okay, so that's equal to x squared minus 0 squared, which is just equal to x squared. And I hit a space so that it renders. And then look what Microsoft has tried to do for us here. It's even tried to wrap our equation because it got so long here. And I could have done other things, like if I hit Shift Enter here, then it ends up. It was apparently not the most elegant thing that I could have done here, but there are ways to sort of break this thing up. The easiest thing to do without getting into advanced tricks like using other sorts of matrices is to just break this into multiple equations. So I could do something like, I'd say, well, maybe I'm going to just copy this in 2. And so I tried to copy the whole thing here, so maybe I'm just going to copy this second thing down here, and then and then I can say, well, I'll just get rid of this portion, so that's all in one line, and then I'll just continue it down here, and I'll say, okay, well then, if that's the case, then it must also be the case that this over here is the case. So I tried to highlight everything from here to here. Again, so I might just have to backspace through some of this. So again, Word is not the most elegant app when it comes to these things, but in a pinch, if you need to typeset some math, it's not the worst thing in the world. So it looks like what I'm going to have to do is just cut the portion that I want and then paste it on top. All right, so for this case, I said f of x is equal to this, so that's the case, and then I just continued it down here, and I said, so if I'm just going to plug in 2u for f of u, and then I'm going to take my antiderivative, plug in my limits of integration, then plug in those limits into the antiderivative, and then I finally get my solution. I say, aha, x squared. So for this case, from 0 to x to 1, then I know that my antiderivative is x squared. And so my last case is I could say, all right, case 3, x is greater than 1. So I'll say x is greater than 1, and then I'll just make that look a little prettier. So control equals. And so here, I can follow the same sort of pattern. So I can actually take this equation and I can paste that down here. And I know this is still going to be the same for this case. I know this is still going to be the same for this case. I know this portion is now goes all the way to 1 because I'm now dealing with x is greater than 1. So that means then that I then need to take these integrals and add one more integral. And if Word will let me, I might be able to paste in some of these so that I don't have to do as much typing. There we go. And so now I'll say, all right, so I've got from minus infinity to 0. I've got from 0 to 1. And so that means I'm left with having to go from 1 to x because x is greater than 1. So this is the case that I'm working with here. And because I know this was word wrapping, then I'll just immediately just start working on the second line here. So I'll say, well, that's what I'm trying to do. So then down here, I know that this negative infinity to 0 is just going to get blown away by 0. So I will get rid of it, or try to. So this is going to be another one of those cases where I have to just cut out the portions I want and then paste them back in. And then this f of u du from 0 to 1, well, if I'm clever, I can look up, well, let's not be clever. So you can know that you can plug back in f of u. For this 0 to 1 case, I just can plug in that 2u again that I did like before. And then for the 1 to x case, I plug in a 0. All right, so that's just plugging those things in. And then so now I just need to end up going and solving those integrals. Well, if you look at this integral here, from 1 to x of 0 to u, well, we've already sort of played that game with the first integral from the x is less than 0 case. So we know that that's going to integrate out into 0. And so I can get rid of that. And all I'm going to be left with is this guy. And so I can say, well, then what does this guy equal? Well, again, we've already sort of done this case where we're saying, well, we know that that's just going to be equal to, if I take the antiderivative of 2u, that's going to be equal to u squared over 2 times 2, which is just u squared. And I am then going to do the little absolute value trick around this, so make this look like I have incorporated my limits of integration, but now I have these constant limits of integration from 0 to 1. So again, that looks ugly, so I'm going to do professional. It should render those as subscripts and superscripts. And so now if I plug in those limits of integration into the antiderivative, then I get 1 minus 0, or I should actually be clear, I get 1 squared minus 0 squared, which is just equal to 1. And that is my third case. So I can say, so putting all that together, I can go down and I can say, all right, so the CDF I get out of this is I just copied and pasted my PDF, and I just look up and I say, well, for the x is less than 0 case, I have a 0. I'll put a 0 in there. For the x between 0 and 1 case, I have an x squared, so I'll put that in. And then for the x is greater than 1 case, and this was the tricky case, I have a 1. So even though this is a 0 here, and the antiderivative of 0 is still a 0, you actually end up getting a 1 in this channel here for x is greater than 1, and that makes it a real CDF. And then that doesn't quite look good, so then I tap that professional again, and it then makes it into something that looks like a respectable equation. So, of course, you could embellish with a couple of words that might help the grader let you know what you're doing, but this sort of gives you the idea of how to go from, so we'll pretend that we didn't have this CDF to begin with. So you can imagine on a homework assignment, like homework D2, I might give you a PDF like this one, maybe a little more complicated one, and you could then break it into multiple cases and then figure out what the CDF, what the proportions of the CDF are for each individual case, and then bring all of those cases back together to reconstruct the CDF, and you're done. So in the case of generating a random variate generator, the next step would be to invert this thing and then run some random numbers into it. That will be something that I'll cover in a different video. For now, this is just how to get from a PDF to a CDF, and actually even do it inside Microsoft Word without having to scribble anything on paper. Okay?